Welcome to our penultimate meeting of the quarter. We're going to be going over a smart foot roll and the reverse foot setup. Dara, if you'd like to take it away on reverse foot.
Yeah, totally. So the reverse foot, it's a pretty common way of setting up your foot. And essentially, it's a setup for an IK leg that kind of allows you to control where the foot is positioned on the ground. So just like not just rotating your foot, but kind of like taking your heel off the ground or taking like your toes off the ground or something like that too. So typically, yeah, it allows you to raise your foot from the balls, toes, heels, or access other rotations of those locations. So you kind of have like pivot points on different parts of your foot. And in addition to the setup, it can be to tilt the foot from like the sides. So what do you need to make it? Simply, you need a duplicate of your IK leg, your IK foot. So just like a duplicate joint chain of your foot without the shin or thigh joint, and a duplicate heel joint. So when you're making your initial joint chain, just make sure that the ball of the foot and the toe of the foot are planted on the origin plane to ensure that your reverse foot can properly peel from the ground. And then with this setup, you also need custom attributes in your IK foot control. And they just need to be simple float attributes. So typically you would have like float attributes for like the rotation X, Y, Z of the toe and heel, and then normally like one attribute for the ball roll. You can make as many attributes as you want. So how do you make it? You would start by duplicating your IK ankle foot joint, and then you would unparent those and kind of, keep your outliner clean, rename it with the reverse foot convention. And then also you would make a heel joint if you don't already have that. So you could just like duplicate your toe joint and then translate it back to where the heel would be. And then you would make an IK handle from for like each like chain of the foot. So like from the ankle to the ball and then ball to the toe. So from like joint to joint, you would make an IK handle. And then you would reparent your foot, your reverse foot joint in the order below, like the heel, toe, ball, and ankle. So kind of in reverse, hence reverse foot. Then you would parent your IK handles to their respective joints. So the IK handle for the toe would be under the toe, the heel to heel, leg to ankle. And then you would directly connect your flow attributes to the rotation values. And then, of course, parent constrain your foot control to control the reverse joint group.
All right. And then next up is kind of taking that to be a smart foot roll. It's a way to kind of simplify those three controls of your reverse foot into one control with two sub-controls to kind of further refine it. It takes your heel peel, your toe peel, and ball roll attributes and merges them into one while replacing them with an attribute that controls when your ball roll ends and when your foot straightens and begins to like peel off the ground in a way. And in this example, it's the bend limit angle and the toe straight angle. And how we expand our reverse foot into a smart foot roll is essentially just deleting your, at first you'll want to delete your heel peel and toe peel attributes and then create two new attributes, which we'll call the bend limit angle and the toe straight angle. The bend limit angle, just make it an endless float attribute with a default of 45 because that's usually what I have as my default value for that. And it controls when the roll begins to have the toe lift off the ground, and the toe straight angle will be an endless float value with a default of 70 that will control when the roll attribute finishes its transition from following the ball roll joint rotation to exclusively the toe joint. In this previous example, you'll be able to see that there when it goes. That the ball roll essentially goes up and then straightens. The ball eventually straightens at about 70 degrees in this example, or it's on its way to straightening at 70 degrees in this example, because of the toe straight angle. And it essentially begins that transition from the bend limit to the straight to the toe straight. That was a bit of word vomit, so I'll be sure to demo it later. But next, we're going to kind of take this in a step-by-step process because it's a bit heavy. So we're going to start with the heel. It's the easiest part. All you need is really a clamp node, which will allow us to control when the limits of our heel's rotation will be. So we'll connect our roll attribute that we made. That's just for the entire rig, and we'll connect that into its input input R attribute, so that that'll tell us where it's located on the attribute, so we can actually start controlling it. Then we'll set our minimum R to -90. So because no heel joint should be bending more than -90, and you're really pushing it with -45. And then note that the max R by default will be 0 because we want our heel to pretty much be shut off after it reaches 0. Then we'll connect our output R to our heel joint to limit when our heel will be active in the peel. Now how we make it for the toe. This will be a bit more intermediate. We'll start by creating a clamp node that will control the bend to straight transition, essentially. So in this case, it is the left foot bend to straight clamp. And we're going to connect our roll from the input R to the input R, the bend limit angle attribute that is about right here, to the, where is it? Okay, there we go, I'm blind. Connect the bend limit to minimum R and the toe straight to max R, because the toe will only begin to operate in between that area. But we can't use that. We can't just pump that clamp node straight back into the toe joint, because if we do, then when our roll value hits 45 degrees, then suddenly our toe joint will snap to being 45 degrees. So we need to kind of connect that to be kind of a 0 to 1 value, so we can remap it into a proper value to use for a roll. So we'll connect the input, we'll create a set range node that will convert it to a 0 to 1 value, and we'll connect our input R to the value X, our minimum R from the clamp node into the old minimum X, our max R into the old maximum X, and then our minimum to 0 and max to 1. Afterwards, we're going to reconvert it back to a rotation value by creating a multiply divide node with its multiply mode enabled. And we will connect our out value X from the set range node into our input 1X and the roll attribute to our input 2X, and the output X will go to our toe rotation. Afterwards, we're going to begin the ball joints. That's going to be a bit complicated because it's going to essentially piggyback off of some of the stuff we created for our toe. We'll start with a clamp node. This will control when the ball roll stops bending. Because in the case of the bend limit, once it reaches that angle, the ball roll stops moving and it starts to retract back as the toe starts to raise. So we're going to connect our bend limit angle to the max R value, and the minimum R will be set to 0. The roll will be our input R. We're going to need to change this back to a 0 to 1 with a set range node in the same process. So just to kind of put that in there. We're going to set our input R to the value X, our max R to old max X, our min R to old min X. Let me just double check, make sure I'm doing this right. Explanation, yeah. Input R to value X, min R to old min X, max R to old max X, min X to 0, max X to 1. Afterwards, we're going to create a plus minus average node so we can start to subtract the value of once we reach that bend limit. So we're going to locate a point where we should reverse the ball roll rotation using the previous slide's set range node, which is this same number 3 set range node here. So first we need to set up our node by going to the mel bar in the bottom left corner of your Maya panel, of your Maya viewport, and type in these two commands. You can just type this one in first, and then click in your mel bar, hit the up arrow, and then change the 0 to 1. So you'll just type set adder of your plus minus average 1 node, which would be changed when we name it, dot input 1d, open bracket 0 to 1. And then we will essentially create or reveal that attribute in our node, and we will repeat the same process. We'll set our operation to subtract, and we'll essentially have 1 being subtracted by the value of whatever our out value x from the set range node of our toe. But that's part 1. Part 2, we're going to create a multiply divide node to merge the calculations of our set range node for the ball calculation and the invert percentage of this into a percent multiplier. So just put the invert percentage of the plus minus average node, or the output 1d to input 2x, out value x of the ball's set range node to the input 1x. Next, we need to convert it back to a rotation value since we're still dealing in a percentage. So we will create another multiply divide node, input the roll into our multiply divide node's input 2x, and then the percentage into our input 1x with the multiply option. And simply put, we'll just connect it to the ball roll's rotation value that we have for that axis. Just a few pros and cons of the smart foot roll over the reverse foot. It does require more nodes since it's not a direct connection, and the bend limit and toe straight can be a bit more finicky to use as first, since coming from an animator who's used it, but it does prevent the issue of easily mislocating your pivot point on your foot control, because if you use too many of like the heel peel, toe peel, you'll eventually, you could end up with a situation where your pivot point is below the foot geometry entirely. Also, typically less attributes are needed to maintain a good roll because the default values of 70 and 45 for those two supplementary controls did work pretty well for me. But with that said, are there any questions that anybody has before we demo this stuff? Okie dokie, I'm gonna stop sharing and I'll just start streaming in Maya so I can get that started. Okay, there we go. You can see Maya right now. Like if I zoom out, nothing's going wacky.
Yeah.
All right.
It's looking good.
All right, dope.
No lag, as of now.
Yeah, for now. So we're just gonna take it from the top. I'm going to just create a basic reverse foot setup real quick. So I'm just gonna duplicate the foot and just input reverse foot into these joints real quick. I don't know how many of you were around for the beginning of the presentation, but typically, at least the way I learned, was make sure that your ball and your toe joints are implanted on the origin or on the 0 point of your seam, so that you can actually. So when you have the heel peel or ball roll, it'll be pivoting from the floor, so the toe will stay on the floor essentially. If you used locators, you could probably get the same effect if you really wanted to place the ball joint to the center of the foot, but I haven't really tried that. I'm just going to unparent all of these objects here and duplicate the toe joints, rename it heel reverse foot, and we'll just translate it back in space real quick. Then I'm just going to hide all these joints for now and go and create a few IK handles. Okay, I'm going to put these tool settings right here. So we're going to create a rotate plane solver on the thigh to foot, and then we're going to create 2 single chain solvers from the foot to the ball and the ball to the toe. I'm just going to name these real quick. Then we're going to reveal all these joints once again, and we're going to parent the foot to the ball to the toe, and the toe to the heel. We're just reversing that entire parent chain right there. So as you can see right there, and we will parent the foot handle to the foot reverse joint, ball to the ball, and toe to the toe. So if I rotate this right now, you can see that it peels from the toe just fine. If I play with the ball, you can see that it basically lifts the ball joint right there. So once that's done, I'm just going to group these together into a left leg verse foot joints group. And we will center the pivot on the foot joint. Going into the perspective view, I'm just going to create a, I'm going to quickly just make a little control. Okay. And I'm just going to grab my script editor real quick so I can just group these together, make a grouping real quick. Then okay. And I'm just going to shape it just so it's easier to select later on. But from here, I'm going to go to my Add Attribute menu. I'm going to see if I can pin this somewhere. Okay, I can't. But before I show that, I'm going to find the dominant axis for rotating the ball. So I just go in here and I find out that the z-axis is where the where I can get my ball roll. So I can just make a ball. I'm gonna stop sharing actually and shift to sharing my Add Attribute menu. Okay. So I'm assuming that you can see this right now, right? But so we're going to want to select, like as you can see, I have the heel reverse joint right now. We're going to want to create attributes on our foot control that we just made for the heel rot Z or X. And it's a float, default 0, min and max set to 0, or just infinite. So we'll just make heel rot Y and heel rot Z. Then we'll make a ball roll, then toe rot X, toe rot Y, and toe rot Z. And now that that's done, I think my share screen just went away. So I'll go back to Maya. Okay. So we now have all of these set up in the outliner. I mean, channel box right here. I'm going to change the panel to the node editor so that I can keep this set up real quick. Where is it? There it is. And I'll just get this out of the way. But we have our foot control, and I'm going to grab our all of our joints that we're going to be inputting connections into, and we're going to just reveal all of their attributes. I'm going to pull out their rotates and expand here. So the ball roll, we noted is the rotation Z. So we're going to go and direct connection to the rotate Z. Then heel rot X. Heel rot Y. Heel rot Z. X. Y. And Z. Then if I go back to perspective view, I can just grab this and we can see that the ball is rolling properly. If I grab the heel rot Z, that it's now pivoting. If I rotate it like this, see the heel is peeling. Toe rot X, toe is peeling, twisting. So that's a basic reverse foot joint setup. I'm going to just quickly parent constrain this. and it works just fine. However, I'm going to now demo how to take this a bit further into making the smart foot roll. So in order to do that, we're going to need to get rid of our toe rot X and our heel rot X attributes. We're just going to delete them. We're going to also, I'm just going to delete the ball roll real quick, but I'm going to quickly go to the add attribute, and we're just going to create some new attributes. Okay. And I'm just going to call this attribute roll. It's going to have a float value that'll go to a minimum of -90, and I just don't really care about the maximum. But the default will be a 0. We'll click add. Then we're going to create bend limit angle, and it'll have no minimum or maximum, but its default will be 45. And we're going to create a toe straight angle, and its default will be 70. So, okay. Switching on back. Now that we got that, we essentially can just go straight into the node editor. I'm just going to go back to it. And I'll grab the heel joint for now. So heel reverse foot joint, and okay. We're just going to create a clamp node and type, there we go, left heel rot clamp. And like I mentioned, we're going to set the minimum of R to -90. The max R will still be 0. And we're going to send the roll attribute into the input R. This is the most basic one, so we can just output the output R into our rotate X, I believe. Yep, okay. So that's pretty much it for the heel. And I'm just going to start dragging in the toe. Let me just close a few windows from the side over here. So once we do that, we're going to create another clamp node. And it's going to be called, just double check something. Yeah, I think it's going to be, I think this is what the name that I went with was left foot bend to straight clamp. And the minimum R will be equal to the bend limit, and the toe straight angle is going to be equal to the max R, and the roll will be our input. So once we got that set up, we're going to need to convert this to a 0 to 1 with a set range node. So I'm going to just type tab set range, and that'll come up. We'll call this left foot bend to straight %. And we'll be basically sending in the input R into our value X, our min R into our old min X, and then our max R into our old max X. Then we'll just click on the bend to straight %. You can see that we got our 70 here, 45. Min X will be 0, and our max X will be set to 1. Then let me just double check everything. Okay, I think we're good. Then we need to just convert this back to a multiply divide node, and we'll just call this left foot roll mult. And I'm going to send the out value X from this into the input 1X here. I'm going to double check to make sure multiply is its default. It is. Then we will grab the roll value and put that into the input 2X. This will be going into its, okay. This is going into its rotate X, if I recall correctly, so I'm just going to send that straight there, and there we go. So lastly, we have to deal with our ball joint. So I'm going to grab that, drag it on in, and the only input it's got is going into its rotation Z. Let me just double check. Okay, yeah, we're starting with the clamp node again. So we're going to create this. We're going to call it left ball 0 to bend clamp. We're going to have the min R be 0, but our max R will be our bend limit angle. And our input will be the roll value, of course. Afterwards, we're going to create another set range node. And we'll call this one left ball 0 to bend percent. We'll set the max x to 1. We'll just basically repeat the same thing. We'll set input r to our value x, min r to old min x, then our max r to our old max x. Afterwards, we're going to need to keep this handy, and we're going to create a plus minus average node. I'm going to call this one left foot invert percentage. And after we do that, we're going to go into our mel bar down here, and we're going to type set adder of left foot invert percentage dot input 1D, open bracket 0 to 1. And once we do that, if I go into the attribute editor, input 1D, we now have like a little bit of a float attribute here. So I'm going to do the same thing, click on the node, click on the mel bar, hit the up arrow, and then change the 0 in the bracket to a 1, and the same thing happens. We're just going to go down here, grab our out value x, drag it on over here, input 1D, open bracket 1, and we'll change our operation to subtract. Next, we need to convert this back. We need to kind of merge these two together. So we're just going to create a multiply divide node. I'm going to call this one, let me see what I called it. Yep, okay. Left ball percent mult. And I'm going to duplicate this just so I have it on hand, call it left ball roll mult. So we're going to send the output 1D into the input 2x, then our out value x into our input 1x. Right there. Then we'll send the output x to the input 1x here. And we'll send our roll from all the way back up here into the input 2x. And send our output x into the rotate z. So that's pretty much our node set up here. And I'm just going to go and see if it's broken or anything. But as you can see, it works just fine. And essentially, we can control an entire ball roll setup in a fair amount, in like a good 10-15 minutes of work, and just with one attribute. But as you can see right here, that's working. Ignore the PV. I didn't set up a pull vector or anything. But if I use the bend limit, I can send it down all the way down here to where it doesn't begin starting to lift off the ground with the toe. However, just keep in mind that you can't have your bend limit angle be higher than your toe straight angle, or else it just breaks and jumps straight up to being straight in the air for a toe. So if I drop it down here, then it's already well off the ground, and if I drop this, it is already entirely being used by the toe. And when we go back, -90, heel is used. And that's essentially the smart foot roll setup.